Hello friends, so today in this class we will be discussing about the topic the cube and the cube roots. So far we have already learned about the square and the square root. Now extending the same reason what we have created from that chapter, we will be discussing about this chapter, that is cube and cube root. So basically when we consider a word cube, where do we usually hear this word? We usually hear this word cube while learning the geometrical shapes, right? In geometry, you know, a cube is a three-dimensional figure with all equal sides. So if I consider this, in geometry, this figure which contains all equal sides is considered to be a cube. You have seen different shapes in the form of a cube in your day-to-day life. A dice of a Ludo, right? The Rubik's Cube. These are in the form of a cube. So basically talking about the cube in geometry, it is a three-dimensional figure with all equal sides. But here in this class we are not talking about the geometrical figure. So here the cube what we are talking about is not a geometrical figure. It does not represent any geometrical figure. Then what actually is a cube? So basically a cube is actually a power of 3, which means that if any number is multiplied with itself 3 times, then it can be expressed as a power of 3. Hence, such numbers are called the cube of a given number. So here, if I multiply a 3 times with itself, then this a is multiplied 3 times, so it can be written as a raised to the power 3. Now this power 3 of any base is considered to be a cube. So while expressing, we call this as a cube. Similarly, if I have minus 4 into minus 4 into minus 4, then this minus 4 is a base which is multiplied 3 times with itself. So I can write this as minus 4 raised to the power 3, that is minus 4 cube. Hence, a cube of a number represents that the given number is multiplied 3 times with itself. Now this cube can be expressed for any quantity, for a whole number, for a decimal, as well as for a fraction. So if I write 5 by 3 into 5 by 3 into 5 by 3. This can be written as 5 by 3 cube. Similarly, if I say 2.1 into 2.1 into 2.1, now here I have taken a decimal number. So this also can be written as 2.1 cube or 2.1 raised to the power 3. So this way, if any number is multiplied with itself, that number can always be expressed as a power of 3 and we consider the cube of that number. So with this now, we will be coming to the actual topic of this class today. So what is that actual topic? The actual topic, what we are going to consider today, is a perfect cube. Now what is a perfect cube? Okay? Suppose if a number is given to you. Now on taking the prime factor of that number, if each of the equal factors can be expressed as a group of triplets, then we consider the number as a perfect cube. So let's say I have 8. Okay? Now if I take the prime factor of 8, 2 4s are 8, 2 2s are 4. Now this 8 can be written as 2 into 2 into 2. Hence here the 8 can be written as 2 into 2 into 2, which means this prime factor can be expressed as a group of triplet of the same factor. Hence I can write this as 2 cube. So here 8 is a perfect cube because its factor can be expressed as a group of triplet, or on the other hand it can be expressed as a power of 3 of any base. Such numbers whose prime factors can be expressed as a power of 3, we call such number as a perfect cube. Let me discuss one more. Let us say we have 343. Now let us take the prime factor of 343. Now which number will divide 343? It's 7. 7 4s are 28. So 6 will be carried here. 7 9s are 63. 7 7s are 49. Hence here 343 can be written as 7 into 7 into 7, which can be written as 7 cube. So again here 343 can be expressed as a power of 3 of its factor. So 343 is considered to be a perfect cube. Let me give you one more example here. Let's say 216. So now let us take the prime factor of 216 and let's see whether this can be expressed as a power of 3 or not. So if you take 216, we'll divide this by 2, so it is 108. Remember, while taking the prime factor, you only need to divide by the prime numbers. Then 2 5s are 10, 54, 2 27s are, 3 9s are, 3 3s are 9. So here now, this 216, when it is factorized, it can be expressed as 2 into 2 into 2 into 3 into 3 into 3. Now here again 216, once its prime factorization is obtained, you can see that the equal factors can be expressed as a group of its triplet. So we can write this as 2 cube into 3 cube. So in this case also, the factors of 216 can be expressed as a power of 3. So we consider 216 as a perfect cube. So a perfect cube is a number which is obtained by multiplying the same number 3 times each. Or a perfect cube is a number which can be expressed as a power of 3 of a certain base. Now let us learn about some of the cubes of the natural numbers. Now 1 cube is equals to 1 into 1 into 1, that is 1. 2 cube equals to 2 into 2 into 2 equals to 8. 3 cube equals to 3 into 3 into 3 equals to 27. 4 cube equals to 4 into 4 into 4, that is 64. 5 cube equals to 5 into 5 into 5 equals to 125. 6 cube equals to 6 into 6 into 6 equals to 216. 7 cube is equals to 7 into 7 into 7 equals to 343. 8 cube equals to 8 into 8 into 8 equals to 512. 9 cube equals to 9 into 9 into 9, that is 729. 10 cube equals to 1000. Now here, this number 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. These are the numbers which are obtained by multiplying the same number 3 times. Right? So here I have multiplied the same number 3 times. Here I have multiplied the same number 3 times. Here I have multiplied the same number 3 times. Hence, these numbers are called as the perfect cube numbers. Now, do you want to see one interesting fact about this perfect cube? The first important fact and the interesting fact is that the cube of an odd number is always an odd number. Right? The cube of an odd number is always an odd number. So see here is 1 an odd number. So 1 also is an odd number. Whereas the cube of an even number is always an even number. So 2 cube is 8, 3 cube is 27, 4 cube is 64. So as you can see, if you check 1, 3, 5, 7, these are odd numbers. And what are the cubes of those numbers? 1, 27, 125, 340, which are also odd. In the same manner, if I consider these numbers 2, 4, 6, these are the even numbers. And what is the cube of this even number? It is also an even number. This means that when we take a cube of an odd number, the result is also an odd number. If you take a cube of an even number, the result also is an even number. Again, we will be talking about the perfect cube, but in a different dimension. So far, we have learned that a perfect cube is a number that can be expressed as a power of 3, right? But there are certain numbers which are not a perfect cube number, but they can be converted into a perfect cube number either by multiplying or by dividing with a certain number. So basically, when we are expecting a question from this chapter, these are the types of the question which will be asked. That what is the number required to multiply this and this to make it a perfect cube? Which number when divided by this and this makes it a perfect cube? Now we will be trying to solve such type of question. So let us take into consideration 81, okay, which is not a perfect cube number. But which number when multiplied with 81 makes it a perfect cube? For such cases, we take the prime factor of 81. So what are the prime factors of 81? 3, 27, 3, 9, 3, 3. So now, this can be written as 3 into 3 into 3 into 3. Correct? Now I need to make 81 as a perfect cube number. And as you know, for a number to be a perfect cube, the factors should be expressed as a power of 3. So here, if I consider this 3, I can write this in the form of 3 cube into 3. Now for this factor 3, it is already raised to the power 3. But for the other factor here 3, the power is just 1. But to make 81 a perfect cube, I need to have a power of 3 for all the factors. Hence here I have got 1. To make it 3, what is required? Here it is required that I need to multiply with 3 square. So that 3 square into 3, this also makes up 3 cube. Hence here, what is the number that needs to be multiplied? The number is 9 must be multiplied. Are you getting it? Let us take some more example. Let me take an example 3087. Again, it is not a perfect cube number, but we need to multiply this 3087 by a certain number so that it results into a perfect cube. For that, let us take the prime factor of 3087. So we'll always start with prime number. So the smallest prime number is 2, but 2 cannot divide 3087 since the last digit is odd. So we'll start with 3. 3 tens are 20, 3 twos are 6, 3 nines are 27. Again with 3, 3 threes are 9, 3 fours are 3 threes. Now 3 cannot divide this, that's 7. 49, 7, 7. So if I express this product in the form of the product, if I express these factors in the form of the product, then this can be written as 3 into 3 into 7 into 7 into 7. So here, this 7 is already a group of 3. We have already expressed 7 as a group of triplet. But look at this tree. There are only 3 here. There are 2 trees here. Right? But to make this a perfect cube, this also should lie as a group of triplet. Hence here, which number when multiplied with these 2 trees makes it a group of triplet? That is 3. Because if I multiply this with 3, then will this also form a group? Hence here, the number to be multiplied is 3. So 3 is to be multiplied. Is that clear? So this way, we'll end up the class today. So in this class, we have learned about the most important topic, that is cube. In the next class, we'll be discussing about the cube roots. Thank you.